Good morning. We'll start with the second unit of the field method in geography, which is basically the sample design. In your research work, you cannot collect data from each and every person or the target object. That is why you need to limit your sample. That means from where you will get the data. So for that we need a proper systematic knowledge and the procedures, how to proceed and how to generate sample and how to generate data. What should be the basic principles for it? So we'll step by step. So sample, as said, is what? A smaller group out of the total population. Okay, it's basically a subset, some proportion of the total population. Suppose you have state as the unit, then out of total households you have to select few. Those selected few are subset of the total number of households. Samples are used in the statistical testing when the population size is too large for the test or to gather data. Suppose you have millions of data, then data entry, then data analysis will take time, and there will be lot of redundancies. That means the lot of data which are basically useless, because as you go closer towards the total number of population, then it will stabilize, like your probability. So if you toss a coin once, that is 50 and 50. As you go on increasing it, so you will get better approximation. Say if you have tossed twice, so you may get 2 heads, so it is biased one. So as you go on tossing it again and again, then the head will be 50%, tail will be 50%. Likewise, the probability is there. Then it is difficult to include all possible members or the observations, because it will be time consuming. You cannot go to each and every household in Arunachal Pradesh or even the district Papumpare or any other district to collect data from all households. So that means by the time your PhD period will be over. So you have to limit those so that you get a reasonably appropriate result. So in that, the processes are, you have to define the population. So as I said, suppose it is population characteristics of Arunachal Pradesh, then whole population is of Arunachal Pradesh is your total population, statistically defined population. Define the sample frame, then select the sampling technique, determine the sample size, then execute sample process. So if you see here, then you will find the population is the larger one and the sample is taken out of it. Then if you have the population, n is the total number, capital N, and in a sample is the small n. Okay, then the mean, that the average condition is mu for the population and x bar is for the sample. Then you have the standard deviation, the delta for the population, and the small s is for that's the standard deviation for the sample. So likewise we will see step by step. So population. In statistics, a population refers to an entire group of people, objects or events which is of interest for some information which can be analyzed as per the objectives. When you design your research, you have certain objectives. We discussed it in the previous classes. So on the basis of those objectives, you have to define the dimension of the population. What will be encompassed in the population definition. Then this statistically defined population may be population of any particular administrative or other defined region, say population or the household or the districts of Arunachal Pradesh, or for the northeast, okay, say, or say Kachar Hills, or you say this Brahmaputra Valley. Likewise, you can define as per your objective. Then say students in higher education in Papumpare, that means you belong or you are a part of that population. So while sample is taken, the scholar may or may not ask you. If you are taken as a sample, then you will be asked. If you are not in the sample set, you will not be asked anything, but you are in the population. Then the hospital in an area. Suppose you are looking for the disease types, treatment, hospitalization expenditures, then you will go to the hospitals. All the hospitals will become your population in that. Then the rivers. Suppose you want the water quality, then you will be sampling from all the rivers, or you can take few sample rivers. Then coffee plantation area. What are the places where coffee is being transplanted or plantation crop going on? Then animals, birds, whether for a particular area, say it is the Lohit district or Tawang district. Likewise, you can define an area, or you can for the bird species, say hornbill in Arunachal. So then all the hornbills will be the population within Arunachal, not beyond Arunachal. So this is there is commonality of characteristics, but variation in the magnitude of characteristics. Okay, they must be common. Okay, then examples, as I said, all the households in a village or a districts, all schools. Likewise, we can take samples, example for the population. Then the sample frame. Actually, what we want, say if you take the population of or the households of Arunachal Pradesh, does that make sense? Or you have to prepare a framework. That means accessibility or constraint. Say remote areas may be excluded. Okay. Then if there is no special requirement, okay, we can exclude those. So unable to respond. So there is a language constraint. You cannot. Say when we went to Mizoram, then we are expecting all can answer because it's the highest literate state. One, the next, second highest one. But there is a barrier of language. So the students could not communicate with the people who are residing in the rural interior area. They cannot, they could not understand the English language or Hindi. So only Mizo. So that is one problem. So you have to define the sample frame. In those cases, you can have one interpreter also. Then when it is not required as per the objectives, so you need not include it. Say educational attainment, we're working on that. Educational status, so we will definitely exclude the children age group of 0 to 6 because they don't form the part of the population. Then pre or post certain time point, say we want the production or some variable, some study that is before the independence or a time frame between 2000 and 2010. So we will not take any data which is beyond 2010 or prior to 2000. Say deciding sample size. Okay, so you have to decide how much should be the sample size, how much should be sufficient. We will come to that later on. Then control sample and validation sample sizes. That means how much you are going to take for the data analysis part and how much sample you will take for the data or the result validation part. If you see, so it goes like this. Say you have the whole as a population, then you have the determined by the sampling criteria, you have the target population, then you have the accessible population, then the sample. Out of this sample, every participant or the respondent is the subject or the focus one. So likewise, you have the sampling framework. If you have a population, then you put a framework. Then out of that framework, that means those who conform to that framework will be taken as a sample. So this is how the sample frame is utilized in designing the sample. Then sample size. This is most important. See, sample size should not be too small that does not represent the population, or it should not be too high that you have repeated similarity in the responses. That means redundancies. So what we should do? What should we be careful? Sample size is a part of the population chosen for a survey or experiment. So we have to take care of that. For example, if the objective of research is to find out occupational status and income of people in Sikkim, that we had gone to Sikkim for field trip, for field study. So in those cases, what will do? That will include all individuals above the age of 16, because we don't consider and the person who is engaged below 16, because that will be child labor. So you will not consider that. Suppose exclusively you are working on child labor, then you will take all the workers or all the persons, children who are engaged of age below than 16. So you have to keep it in mind. That comes into the framework. Then there will be a lot of data redundancies. That means excessive data collection leads to repetitions of the data. So sample size of large size should not be opted for. So it should be restricted to a reasonable one. Hence, a wisely decided sample size will be good for representation. So what we should decide or look into? The sample size can be determined on the basis of population size. Then confidence level, you are confident that 95% it's valid, 5% error. Then margin of error in the data. So this is, for this you can go to the www.surveysystem.com. Then in that sscalc.htm, that means sample size calculations. So in that, if you enter like this, then you will get, say, 95% confidence interval is 5, population is 50,000, then calculate, if you calculate, then 381. So as we increase the population, then the sample size does not increase proportionately. Rather, if you see the population of size, confidence level 95, margin of error is 5%, then you need to have 80 samples. That means almost 80%. But if you go to 1 lakh population size, then with the same confidence level of 95% and margin of error is 5%, then you will see that the sample size is 384 only. So 5 lakh 384, 10 lakh is also 384, 1 lakh 383. So if you increase the population, there is hardly any increase in the sample size beyond 5 lakhs. Okay, so if you take more samples, that means that will be redundant. But in some cases, we may go for it to find out clustering. So we'll discuss those things later on. Okay, then this is the population and the sample. How? See, if you look into it, then the relationship is like that. The upper curve, that the black line, is for the population, and those dark blue dots which are moving around are something like 100 samples, and out of the total population, any 100 sample is taken, and the total characteristics are not changing beyond the total population characteristics. Everything is between, say, mean, then the median, then the standard deviations, all will be within the total. So you can see the graphics. So we are altering the samples 200 times. Still the characteristics are limited to the population characteristics. Okay. Then we'll go for the next is the sampling technique. Samplings are basically two types. One is the probability sampling, another one is the non-probability sampling. Now, in probability sampling, what we do, we give every entity or object within the population equal importance. That means everyone has a chance to be picked up as a sample. But in non-probability, it's not that. I like you, I will pick you up. Okay, he likes this place, so sample will be from this place. He likes this group, occupation group, he will take the samples from that. That means all have no equal chance to be picked up as a sample. So it is discretionary. It is subjective to the researcher. So if you see what are the types of probability sampling are there, one is the random, second one is cluster, third one is systematic, fourth one is stratified random. Then in the non-probability, we have quota sampling, snowball sampling, convenience sampling, and the purposive samplings. All have their own importance. So there are differences in the sampling methods. By definition, by sample, time taken, results, and hypothesis. If you see, by definition, probability sampling is also known as the random sampling because everybody has the equal chance to be picked up as sample. In non-probability, it's non-random. That means some criteria is there in the mind of the researcher. Then in terms of sample, since there is a method in deciding the sample size, the sample, the population demographics is conclusively represented. That means statistically it is a true representation. But in non-probability, you cannot guarantee it has a true representation. Rather, it will be skewed. Then time taken, random means it longer because you have not designed, you have to move in a haphazard way, you have to go for different places, then the different objects. So it takes time. And in the non-probability, time factor, reducing the time factor is also in the mind of the scholar. So he will or she will fix the sample accordingly. The results in the probability sampling conforms to the total characteristics. It is unbiased. But in case of non-probability, you cannot guarantee that there is no biasness. There will be some things. So there is some speculation is there. Hypothesis, in probability sampling, there is an underlying hypothesis before the study. So that is based on the certain principle. In the non-probability sampling, the hypothesis is derived after conducting the research because you have something in your mind to collect the sample. So thereby you can think, you can alter, you can add later on. So we'll discuss step by step the types and how to go for it, how it is being obtained for the probability sampling. First one is the random sampling, that is without replacement. Okay. So see, random means everyone coming to the top at one time. Suppose you are picking off the object or the sample which is at the top, then anyone will be there anytime. So it is purely random. So the other one is cluster. See, cluster means you have to find out a group. So as here the variables are moving, you can go for a sample. This is a rough representation just to understand. Then the other one is the systematic. So systematic means every fourth, every fifth, every 10th Suppose there are population size is 1000 and you are going for collection of 100 samples. Suppose that means you will be picking up every 10th object or the 10th person as the sample. Okay, then we'll go for the another is the random, stratified, cluster, systematic. So in that we have to decide first what sort of probability sampling we are to employ. So in that, here is a matrix. Okay, direction to consider sampling. First one is, can data be collected from the entire population? If yes, then there is no need of sampling because that's 100%. Total population and sample population is 100. No need for the sampling. Then must statistical inferences be made from the sample? If no, then you go for the non-probability sampling. Okay, if yes, then does the research require face-to-face contact? If yes, then the population is geographically correct. No, then go. So like this you have to see. So what are the things? Use stratified random sampling, use stratified systematic sampling, use simple random sampling. So likewise, this is actually good flowchart to decide what sort of sampling you should choose. Then we'll discuss every sampling probability sampling types. So there are pros and cons and how we can actually work it out. Random sampling is a procedure for sampling from a population in which, number one, the selection of a sample unit is based on chance. Equal probability, everybody has equal chance. Then every element of the population has a known non-zero probability of being selected. That's a statistical term, means everybody has some probability. Then random sampling helps produce representative samples by eliminating voluntary person's bias. So there is nothing like, okay, I have come forward, now I have reached, you accept me as a sample. No, that cannot be. That means that will be biased. Then guarding against undercoverage bias. So you cannot have something that undermines the or does not conform to the norm. Then how it is being done step by step, we can work it out. Steps for the random sampling. First one is make a list, that means the population. Assign a sequential number because you have to progress 1 by 1, 2, 3, 4 by 5, and accordingly you will be selecting any requisite object or entity. So you have to assign them a sequential number. Find out the required sample size. Okay, then use random number generator to identify who will be the sample. Okay, then how you can, once you have done, how you can calculate what should be the sample size? You can go simply by, as we discussed, confidence level, margin of error and the population size. Then accordingly, if I have 95% confidence level, margin of error is 5%, chances of population proportion is 50. Generally, if you don't know, if you have 50 means half. So that is the maximum number of samples you will get in the calculation. Then if you have 1000 population, then it is 278 sample. You can go use this website and online calculation, you will get like this. Then next is the, once you have given them number 1, 2, 3, 4, 5, 6, 7, 8 like that all, then suppose you have how many? 1000 population is the total number is 1000. So lower limit is 1. That means you have numbered from 1 to 1000. So how many numbers you have to generate? This is 278 from here. sample size 278, so them 278 numbers. Then allow duplication of the results, no, as survey is done once from a respondent, no duplication, you cannot visit the same respondent again, so thereby we will opt this, no duplication or the duplicate sample is allowed. Then as the sequence is followed, ascending order will give us some advantage, because we cannot have 1, 30, then 13, then 115, then 17, then 788, then 205. So that's difficult to identify and select. So we will go in the ascending order. Then type of result to generate, whether it is integer or decimal, as we are numbering them as integers 1, 2, 3, 4 discrete numbers, so we will select that integer, then you will go for the generate. So once that is done, your number of random number is being generated. See, in this case, if you see houses are numbered, generate random number, survey houses accordingly, household survey. What we do, see, this is from the Sikkim, one of the student has done this, so good thing. So if you see, the houses are being numbered, RH, room take, house number 100, 101, 102, 103, like that. So if the random number is picked up as 102, then this household will be surveyed. Okay. Then next is the stratified sampling. It's basically to compartmentalize the whole population on the basis of certain criteria. The whole population is divided on the basis of certain criteria like income, high income group, medium income group, low income group, but total population is there within. Education, so say primary education, secondary education, higher secondary education, then higher education, like that you can. Religion, different types of. State of origin, suppose you are looking for migrants, then from which state they belong to. Region, state or district, so you can classify accordingly. Then the stream order, say you can take first order, second order, third order as one group, fourth, fifth, sixth as another group, seventh and above another group. Then the soil group, or the slope categories, say 0 to 10, 10 to 20, 20 to 30, you can get slope categories and house. In that way you can read. Then you go for the random sampling. Okay. So stratification, say for example, we have this sex ratio for the Arunachal Pradesh. We have plotted it. Now we know how the sex ratio is being distributed. So the stratification of administrative circles on the basis of sex ratio. Now we have classified below 400, 400 to 600, 600 to 800, 800 to 1000 and above 1000. So now we will distribute the sample on the basis of these 5 strata or the groups. So the stratification can also be done as in your geography. We can compartmentalize into divisions of area, latitude or longitude wise. Say we have Arunachal starting from 93 to 97, 93, 94, 95, like that. 92, we can divide into 6 groups, 6 longitudinal zones. Then say this is one district of Arunachal Pradesh, so we have latitudinally divided into 7 stratas. So no area is being left unrepresented. That means every area, every part of the district is going to be definitely represented. So the the purpose is also there should not be any left over portion. So every part from that district there will be some sample. Then the cluster. So if you see the diagram, then there are clusters on the basis of 3 parameters. Suppose you have data, definitely when you are going for some research, you understand or you find out the preliminary supporting characteristics or data. So you have taken 3 variables and you have seen the clusters. So you can take the cluster mean and from where they belong, what, and accordingly on that basis you can go for the sampling. This is variable sampling. We'll see that the population must be as heterogeneous as possible. Then only you will get cluster. If it is homogeneous, then it will become one cluster or one point itself. If the data is same for all, then it will be a point. Okay, the population should contain distinct subgroups of different types, that is natural subgroups. Else what will happen? There will not be any cluster. Each cluster is a small representation of the entire population. Even if they have variations in their characteristics, but they represent the entire population. Random samples are then collected from each group to make it probability sampling. Then spatial clusters, as you said. So this is again the same thing. What we have done? We have tick marked or selected all the households. Then we will visit those tick marked 3 areas because they are contiguous. So we will take the sample. So these 1, 2, 3 are the area wise cluster samples. Okay. Then another one, this is on the right top side, you have the Sikkim. On the Sikkim, the southern half, you have the settlements. In the northern, it's completely uninhabited. So in that case, what you can do, we can put the numbers of grids 1, 2, 3, 4, 5, 6, like up to 16. So there are 16 grids, and suppose we want 5 grids from where we will collect data. So what you can do, we can go for generating random numbers. Okay, 1 to 16. What are the result? 1, 3, 9, 11 and 13. So accordingly, see this 1, 3, 9, 11 and 13 will go to those circles and collect data. So this is how the random clusters at the spatial level are done. Then if you see the clusters using variables, so in the right hand side there is the dendrogram, cluster dendrogram. So you have data, preliminary data, and you analyze those. Then you go to the field and suppose first one is circle 1, circle 2, circle 3, administrative circles. Then accordingly you can go to those circles and collect data. So how many you have? 1, the blue, yellow, then black and the red clusters. So accordingly you can go and collect data from those circles for the household or for anything you can go on. But this is the principle. Cluster analysis used, and you should have the known variables beforehand. That means you should have or must have the secondary data to understand the characteristics, and after that on those groups, out of those groups you can go and collect data. You can again use the sample from that circle also, from that block or the district also. Okay. Then systematic sampling. Sampling from a larger population are selected according to random starting point but with a fixed periodic interval. This interval is called sampling interval. It is calculated by dividing the population size by the desired sample size. As you said, suppose you have 1000 and you have to take 100, then every 10th will be the sample. So in this case, every respondent in this diagram or the animation, every respondent coinciding with red in the sequence is picked up as sample randomly starting from 23. It can be from anything, say 23, 44, 1, even 17, 59 also. So if you start with 23, then the next is 30, then is 37, then 44, 51, 58, then 5th. After 60 we have to start it again from the 1, because we have in total 60 samples. So likewise we will have a systematic samples. Every individual has no chance as such, but as it is randomized, so everybody has a chance to be picked up. It depends upon, suppose I picked up the first sample will be 23rd observation or 23rd entity, then that will decide who will be the next. 23, then 30. It will never be 26th. Okay. Suppose you started with 1, then next one will be 8th one. In that way, everyone has the equal chance, because everything is random there, but it is systematic. Then we'll go for the non-probability sampling. That means choice. In many cases, there are restrictions in exactly utilizing the randomized or probability sampling. Thereby, we go for non-probability sampling. But the problem is that there are biasness associated with it. Every entity population is not equal to become a sample. Okay, we'll see step by step how it is. Then rationality of selection sample is a choice or preference. Then it also differs from scholar to scholar, researcher to researcher. I feel this X criteria is good, then the other one may say the Y criteria is good. So it varies from person to person. So thereby biasness is always there, but it can be minimized. There is no surety that the samples represent the population well. Suppose we have taken the upper side range, then our result will be skewed. If you have taken the lower side groups, then again it is also skewed. The same way, there are decision box it is. On that basis, we can decide what sort of non-probability sampling we can select. So like what we discussed in the probability sampling. In the decision box, you have to see the criteria. If it is yes, then you have to go for one sampling. If it is no, then you have to go for another option or look for another criteria for decision making process. Then if you see the non-probability sampling, there are 4 types basically, and many more can be added. Subtypes can be added: quota sampling, snowball sampling, convenience sampling, and purposive sampling. Remember these 2 diagrams. We will see how we utilize this in our field trip. Okay, so quota sampling. Target sample is selected non-randomly according to some fixed quota. Okay, so we know how much quota. Say I want 50% of this, I want 20% of this, I want another 15% of this, another 15% of that. In total 100%, but I am giving weightage like 50% to one group, 15% and 15% to 2 groups, then 20% to another group. Total 100. So I am getting sample out of the total population, but the preferences are not same. Quota is allotted. So in that way, say here we will see the example. So how many households? See, this is the district of Arunachal Pradesh, number of households. Okay, then we will see proportional sample and non-proportional sample too, because quota sampling has 2 types. One is the proportional and non-proportional. Proportional is less biased and non-proportional is more biased. This is done to avoid any non-inclusion of any segment. So I don't want to exclude or I want to exclude. So in both ways I can work. So how many? That's households are 2,70,577 households as per the 2011 census. So again, confidence level is 95%, and as the area is too large, so I want my margin of error to be strict, so only 2%. So in that way I will have 2,380 sample size. Okay, so accordingly I will go see here. So 200 proportionate sample size 2,380. So on the basis of households, so it is 10,062 households in Tawang district. So I will have 89 samples. Say Papumpare, 35,730 households, so 314. So then Anjao districts, 4,612 households, so I will take only 41 samples. So likewise in total I am having 2,380. So sample is good enough, but it is distributed proportionately. But if you see the non-proportionate, so I will round off 89 to 100, 160 to 150, 120 to 100 likewise. Then I am thinking there's Papumpare and West Siang, they have urban areas, so I should go for little more because their characteristics may be little different. So I'll go for 500 for the Papumpare district. Then West Siang I will go for the 300 districts. So likewise, I have a decision, overriding decisions to with me, so that I can change the requisite proportion of samples to any number. So that's why non-proportion samples, that may be taken as a good practice, or even taken as a bad practice, because it will be skewing the result. Then next is the snowball sampling. The snowball is basically taken from the word from the snowball. As a snowball rolls, it picks up more snow. That means it increases. As you roll it, small ball, snowball, then it will collect more and more snow. It will become large one. That is the typical theoretical aspect. Anyway, in that way, what happened? As you roll, that means it passes through to the next, to the next, to the next. Likewise, respondents who have similar experience, they will, suppose you are asking person A, what about your experience in insurance, vehicle insurance? Then he will say, okay, my experience is good, or my experience is bad. I know few persons whose experience are also bad. Okay, that means he will refer it to another person. Then they will refer to next set of persons. So likewise, you have one to next level to next level. What it is called? First wave, second wave, third wave. So it is like contagion, spreading effect. One, so you have the friends, their friends, likewise. And suppose your objective is on the top right, objective is assessing angling activities in Papumpare district. Okay, suppose somebody is saying, yes, I know this person in the lower Subansiri. Will you go there to collect information? No, because that's an invalid reference. You will not go there to collect data, because that is beyond your what you can say, geographic research area, geographical boundary. So another one is the convenience sampling. You recall how we collected data during our field trip. We stopped at one village, then always spread out. Then we can say it is random. But when we were waiting at Ravangla, do you remember that place? There was a breakdown of the vehicle. We had to wait for a long time. So that time, some of the students collected data. And as they have to be near the road, so what they did, they collected data from the houses which are close to the road. So road and close to the road, that means it is only a convenient household to be surveyed. So it is called convenience sampling. It relies on the data collection from population members who are conveniently available to participate in the study. Okay, it's like avoiding difficult terrain or the terrain area to collect data. Easier target population, say according to access, or who will go to that far place, or I will collect from my neighborhood. Okay, then attitude, you will definitely avoid a person who is not willing to share data, or his behavior is not good, or somebody is having a good hospitality, or then it will be attractive place to go visit the household. Likewise, there are certain convenience as well as inconveniences on the basis of which the sampling is done or avoided. Then in the purposive samplings, we can see through another example. Okay, the focus is on a particular characteristics of population that is of interest. Target sample is determined on the basis of the judgment of the researcher. Say somebody is working on the agricultural produce, the benefits. So there are many agricultural types, or the crops cultivated: wheat, soybean, potato, maize, rice, vegetables, mustard, ginger, millet. So instead of collecting data of all types of crops from all the districts, I can see the crop, major crops or the dominant crops in the districts. So which is available in the www.agri.arunachal.gov.in. That means apagri.php. In that you will find the district wise major crops. So in Tawang, I can only go for those farmers who are cultivating wheat and soybean. West Kameng, potato and maize. So likewise, if I go to the lower Subansiri, they are good in the off-season vegetables and ginger. So I will collect data from those households who are having who are growing off-season vegetables and ginger. So likewise, Tirap, tapioca, betel leaf. So I can decide what sort of sample data I have to collect. So this is why it is purposive sampling. Then another one is the literacy level. So if I want to know why and what for the literacy varies from place to place, from region to region, area to area, district to district. So in that case, I have data about the literacy rate for the whole of Arunachal at circle level. So what I'll do, I'll go for one hotspot analysis. That means hotspots, good. These on the higher side. Then the blue are the cold spots. Okay. So accordingly, I can concentrate more samples on those areas. Why the literacy is high? What are the factors contributing to it? So in that case, I will take more samples in the red colored areas. Okay, say most of the Papumpari district, then West Kameng district, then the East Siang district, then from the Changlang. So likewise, but when it comes to the low literacy, now we'll go for the Kurungkrume, those areas. So it is a purposive. That means from where I will get good range data. So on the basis of my objectives. Okay, so in this way we can think of how and in what way we can best utilize the sampling procedure and go for the collection of data. With this, thank you. Bye.